and I'll just quickly make sure I see the right screen. You guys can actually see everything. All right, so you should be able to see virtualization now. Okay, so let's jump on with this. Can you just first tell me, can you see virtualization? Then at least I know I'm on the right track and I'm sharing the right screen. So you should see virtualization about foundation. Okay, thank you. All right. So virtualization is the foundation of cloud computing. It's where we basically, want to do things. And what it allows you to do is try to take hardware and then virtualize it. And that's basically what we're looking at. So at the end of this objectives, you'll be able to describe the essence and value of virtualization, understand some of the mainstream virtualization technologies, and also grasp the principles of how they obviously use virtualization. So it will basically be about, what is out there, how these guys use virtualization. So we're getting back to this graph we saw the other day when we looked at server basics, where we said that IT resources are independent, right? Which means that in this scenario here, you have to share your CPU, your RAM only to one particular piece or Windows OS in this case. And so that's a bit, let's say over resourceful. It's mainly you underutilizing your hardware because your Windows server might need only what, eight CPUs, right? And you have on the server 16. So now you basically have eight remaining CPU idling, used for nothing. So that's kind of the whole thing where we said, and Windows probably can't get on less than that. But I think this is where we're saying it's all independent and it can be, wasteful. Again, also you always must be tightly coupled with the hardware. What we mean by that is this hardware and the OS must talk to each other, right? So that's kind of the whole thing between this setup. Now, when we look at virtualized, why we have this is that we have now the service itself, but we have a virtualization layer. And so what this creates is we have virtualization where these becomes a resource, right? So instead of having one CPU, you now have 32 CPUs together, because you're adding up all these services CPUs. You might have 128 gigabytes memory, right? You might have 64, GPUs, depending on how they build the species, and you might have maybe 20 terabytes of data. So it's more or less combining individually what was here. I'm just making a rough estimation on that. And then from that resource pool, you can now allocate for Windows 10. You can say, okay, I'll allocate to, then I have 30 remaining. And so with that, you balance your load across how many instances you want to have. And that is virtualization. Now we're going to look at really where the concepts comes into virtualization. So this part here would basically just show you, your physical server. Remember, we said that your OS and your hardware is tightly coupled. So these two are tightly coupled to each other, right? They are connected. Your hardware says it's hardware to the OS, and then the OS runs the app, which is probably, I don't know how many apps a server can run, but that's what it runs. If you look at a virtual machine, now a virtual machine is in this case one of this. It's one of these that you see here, right? That's a virtual machine. Now on a virtual machine, you have the following. You have the hardware from that server. You have the virtual machine monitor, which in this case is the hypervisor or the resource pooling. You see this part here, resource pooling and the virtualization layer. So that is this part here, right? This part there. And then you have your VM guest machine. So whatever VM you decide to install virtually, you decide could be a Linux machine, um, it could be a Windows machine. So it depends on what you run here. That's what you decide. And then you then have your guest OS on top of it. Now, what's a guest OS? Is that you would have an operating system running on top of it, and that will be the VM's OS. Because the VM you can make the VM a server VM, you can make it whatever, but your guest OS will run on top of it. So that is kind of the concept of virtualization. Now, not to confuse you with this particular table, it's more or less you have your hypervisor. Let's say your hypervisor is, I can't say if it's VMware because it might be anything else. And then on top of that, you have your virtual machine that runs like the OS. So this could be, let's say it's VMware. And then VMware would have a guest OS that will run as a VM and so forth. And that's basically the whole virtual machine. Now, when we look at the history of all of this, where it started in 1964. IBM launched their own VMs, and then at the end, we get to 2008, where we added Hyper-V for Windows servers on Windows, and then we had 2008 where Linux evolved. It started as a container. In 2008, they added KVM as a port to it, and now in 2011, they then created this virtualization alliance. And I think we've covered this slide. And then obviously Docker launched, right? So this was the Linux container, which was called LXC, and then Docker, and then Rocket is also just a container. So now, when we look at the two ways of how you look at virtualization, there's also the type of virtualization that you want to apply to a scenario. You have the full one, you have a para virtualization, and you have hardware assisted. What this means is that your virtual machine monitor, that little thing, this year, your hypervisor, right? It will decide on which type of virtualization. So full means that it virtualizes your CPU, the memory, your input output devices, but it doesn't modify the guest OS and hardware. So that's full virtualization. So you have full capacity on the load on the CPU. It's directly attached, it's almost like directly attached. And then you have VM, which is basically para virtualization. And again, here you're taking your CPU and your memory and the go in and the guest OS. So you need a guest OS there to coordinate with the hypervisor. And because of that, that's now a top overlay that you're adding on top of that. But it provides high performance but poor compatibility. That's one thing. Then you have hardware assisted. Now you have basically a really full virtualization, which basically looks at question is possible to run Linux on Windows machine, and so what? Yeah, you can run it. You can run it as VirtualBox, which I just showed you earlier. You can run it also as creating a they call it WSL, which is Windows. It's a Windows flavor, so you can run Linux from the Windows Store, the App Store, like the Windows Store, and then it installs it onto your Windows, and you can run it like that also, without needing to install it. You can run it from the Windows Store. I'll try to show you that early, if I have time now with on the Windows 11. All right, so that's what you can do. So again, getting back to full virtualization, it's full compatible is good, and you don't need to modify your guest OS. And this is basically eliminating the difference between the two, between software virtualization and other virtualization methods. So those are just the big ones. We'll get to the look and what it looks like really. But those are the three different virtualization types. And if you plan to do the exam, they'll ask you this question to understand, can you differentiate between the three. So now we have partitioning, which again is what happens in a VM, right? So what will happen is that what it says in the whole virtualization characteristic is that you can run multiple VMs on the same physical server. So this is the server here, and the server basically allows you to run this multiple VMs on top of it. But the server will obviously have, maybe it could be a hypervisor, Hyper-V, and then it would obviously assign a VM on top of it. But remember, with Hyper-V, you need to have the Windows Server running in order to run it. So that's the overhead you're adding on top of it. But I'm just making an example. And also, it needs to have isolation. That's one of the characteristics. So if one of the VM goes down, you can basically, isolate that event. So that's what you want to have. VMs running on the same physical server are isolated from each other. You don't want to have that an effect on that network. So that goes down, it doesn't affect the rest of the VMs. Encapsulation. So it's basically encapsulated into independent files. So you can move that VM quicker. So what it means by that is that when you save a virtual machine, you save like the virtual disk. So I think if I just show you this VMware Fusion. Just to see, you guys can see the screen that I'm popping up right now, which is Windows 11 64-bit ARM. Just to see if my screen is still sharing. Okay, cool. Right, so this is basically virtualization. So this is me virtualizing a Windows 11, and you can do it vice versa using VMware Workstation in Windows. Then, so what you can do is, in my case, I'm gonna just show you the setting side of it, where the virtual disk is stored. So you can see here, there's the VMDK, right? So that VMDK there, those are just how you store your virtual machine. Now, if I change this to that, it will tell me my operating system won't be found because I'm changing that descriptor file. And so again, this is just showing you I'm virtualizing my SSD in NVMe as part of 100 gig for this virtual machine. That's basically what I did, which I think is too much. It's actually too big, but it's fine. I'll just delete it when I have time. And so that tells you the VMDK is that example of encapsulation. You've encapsulated everything of that VM into one virtual disk, right? And it means you can move that. So I can take this virtual disk that's here and move it, to another virtual machine and rerun it again, and then it will just take that information and use it like that. And that's the job of the type of file type, which is called encapsulation. So by doing this, I can now basically start up this VM, and then it will run this virtual machine with that VMDK. And I can copy the VMDK to another PC or server, and I could run it like that. So that's encapsulation part. When you look at hardware independence, again, here it's about what I just said now. Your VMs can run on any server, so really no modifications is needed. And that's the nice thing about virtualization. So you can move it to anywhere and just run it as long as you have the resources available to run it. So here's the advantages of it. We said OS is decoupled from physical services. You can migrate, you can scale, integration is easy, and everything is just one file instead of a lot of files. But before that, you had problems where everything was bounded to physical servers. You couldn't migrate, you couldn't scale, and your service takes up a lot of space where you have to put them. So again, your virtualization allows you to have one or two servers or four instead of several services, which takes up space. So again, when you look at virtualization, again, you have type of issues. And so the type of issues that you get is a simulation of CPU instructions, and that means that the CPU sends instructions, that can read and do certain things, and also it has privilege instructions, which means that it can do certain things on a kernel mode. And that's basically what are the things that the virtualization tried to resolve from old Windows or old type of non-virtualization scenarios, because you don't want to have too much privilege instructions, because you want to have the highest level, and I'll speak to you that in the next slide about the ring of how CPUs operate. And then again, you can enable multiple VMs to share the same CPUs. That's also another thing which is part of virtualization. So next you will see basically how does CPU virtualization work with the ring technology. So with rings, it's just basically hierarchy, the level of order. Okay. So ring 0 means you have the highest order. Ring 3 is obviously call it an order where your level is certain things that you can do and certain you can't do. So on a normal Windows PC that doesn't have any virtualization or Linux, you have the OS kernel, which is obviously the brain of the OS, and your user are sitting at ring 3, which means that you don't have really permission to get to ring 2, ring 1, and so forth. So you can only access straight to the hardware structure. So that's the full way of how you would use a PC. Remember, you run a application, it goes into your memory, it uses the memory, and that's it, or you use a CPU. There's no virtualization involved. When you look at full virtualization on binary translation, what it means by this is that you now have the virtual monitor machine, which again in this case could be VMware, sitting there, and then you have a guest OS on top of it. So what in this example is that your guest OS needs to work through your VM your VMware hypervisor in order to get access to the hardware, in order to use some of that CPU or memory that's available. It needs to work through that. So that's a full virtualization based on that. And then when you look at your hardware assisted virtualization, um, you have basically your hardware full is basically you have your VM, but now the VM has moved the ring down. Sorry, not the VM, the virtual machine monitor. um, what it's done is it moved to root mode, and root mode means that it has now more power to your kernel because it is kind of tightly coupled in a way into the kernel or to the hardware. So it's now set at root mode and not ring zero, whereas the older ways used to be ring zero. So that's kind of how the CPU looks at it, because this is non-root mode, so you don't have permissions really on that level, and this is basically how you look at the operating system. Now, this goes back to what I showed you in hardware in kernel, the kernel, that whole onion graph. It's basically that particular permission structure. So when we look at the following, we have virtualization on CPUs. So what we do is we have, in this case, four CPUs, right? So this is a four core basically server. And what you can see from that four core, is it four core? I'm just checking. No, I don't think it's four core. It could be more cores, because we virtualizing into one, two, three, four, five, six. So I've got six CPUs, virtual CPUs. So that's six virtual CPUs, and then six virtual CPUs, which means it was three cores. Let me just see here. Yeah, three cores. So there's one, two, three cores, and then it's connected to the kernel. So the kernel basically has the processors running. Yeah, so it looks like um, it's a six core CPU. I don't know. Trying to figure out here based on reverting back to that. But at the end of the day, the amount of cores you obviously have to multiply that by, not multiply it, you times it by two in order to know how much cores you're going to need. So for instance, if I make an example of what can I make example of? For instance, the VMware that I have here, Fusion Compute. Is it now? If I now basically want to create a new virtual machine, so I can go new, then it will ask me to create a new virtual machine, and I'll say go next, new. Then you choose the operating system, you go new. Then you create a virtual disk. So for this, I'll just create an 8 gig. That's fine. And now you go to customizing. So when you customize, yeah, I'll just give it a name. So when you customize, you can now go to the CPU and memory. So you can see I've got two cores available, but my capacity um, that I have is 12 cores. My whole CPU has 12 cores, right? Or my whole PC has got 12 cores in this case. So I can use two cores for this particular VM I want to set up. That's what I mean by that. But again, you also have your memory available also. So it all depends on how you view it from the settings. I think this doesn't really give me much information, because I wanted just to show you how you determine your cores on availability. Maybe if I use VirtualBox, let's see, VirtualBox gives me that. So with VirtualBox, you can see settings here, and then you'll see system, and under system it will tell you your processor. So you can see I've got 24 CPUs. That's why you could see 12 is available. That's kind of what I wanted to show you. So I've got 12 CPUs um, for virtualization on my laptop, but I can only use 12 for the virtual CPU. That's kind of what I lean to. So now you understand what I mean by that. So it's always you taking half of what you have available. So I can only, if I look at it, I've got 12. Just go back to my system here. 12. Then basically 24 is what I can virtualize to. Yeah. So it's times 2. Yeah. Right, so there you can see this example is basically taking that you have six CPUs, virtual CPUs available here. It's only one, if you can look at it, right? So it's six, which means that this should be, what's my calculation now wrong here? Should be three cores. Yeah, should be three cores. Yeah, so that will be three cores, because here you have your one, kernel that's running with that, and you have another here, but I think it should be six. It should be three, and that should be six, and in this case, is that. It gets tricky, but it all depends on if you know how much cores you have, and then you work out, the threads, because a thread basically gives you each CPU. In most cases, have 16 threads. So if you had a virtual CPU of 32, you would take that 2 times 8 times 2, and then you will know what you have. So the threads is normally the calculation you have to look at. But in this example, I'm trying to figure out what was this. I think I'm just checking the notes in the slides and I'll know. Yeah, so it's 32. It's 32 cores that we have in total. And each of this has 16 threads. So a total of six, yeah, 6 CPUs per time. Okay. Yeah. So you can't exceed the maximum of this also because you have to consider other things running on your PC also. Right, so let's look at memory. So that's the CPU. If you look at memory again, you can start from address 0. You can assign many blocks to addresses. But regarding memory basically gets allocated accordingly how you use it. So if you look at a virtual machine monitor, now this is your hypervisors that you see here. This is like two servers running. So you can see here basically if they together, the virtualization is working together, VM1. Sorry, not, I mean, this virtual machines. So this is two virtual machines running on your PC. So it's a virtual, and that's also a virtual machine. And so you would have maybe Windows running here, Windows OS, and maybe Windows here running, depending on what you're running on there. Maybe you would run your DNS server on here, and maybe you would run your DHCP server on here. Just an example. So now what will happen is that server needs memory requirements for the VM to work. So it will use from the virtual guest address that's there, and then it will take the physical address that's available, and then allocate that from the host. So the host would have this in total, and then from there it will now assign. Let's say you want 2, and I'll just make an example, 8 gig, and you want 8 GB of memory. So that's the amount of RAM you're allocating to each VM. So it will randomly take, from there and so forth. So that's kind of how, your VMs will use memory from a set pool if you have a host set pool. And again, if you look at KVM, it virtualizes and uses the physical memory and allocates to the VMs in this scenario. All right, so might have input output also, which is also another example, and that's also if you want to have pass through through certain devices. So like a GPU want to assign to a particular VM, you would use GPU pass through and so forth. All right, so input output. This is just showing you the type of virtualization. Here you can see they use QEMU or KVM as the guest machine, and that basically allows you to virtualize your hardware in that file. So I showed you earlier the I think the VM to the hypervisor. So now you also have a QEMU to also a hypervisor, and so this is an example of a full emulation. You have your device there, you have the driver, but you have the hypervisor sitting here that then connects, through the VM, through the native driver in the app. And then on this side, you have a kind of shared Virtio. Now, Virtio is how Windows normally use the driver. So what it means is that you want to have a special driver that sits there in front of your VM and your hypervisor, so that your whatever you're trying to access, it's available. So they have like this kind of shared memory here between the two. And so this is just assigning a PCI device. So if you have external device you want to add to the server, you would then basically have it here on, let's say this is a physical NIC here, the outside, and then you would then add that, as part of your network. But then obviously, the guest always will assign that based on how it's configured. So that is virtualization. Now, mainstream technologies, you have Zen. Zen is common. It's one of the virtualization technologies. Not going to go much into that. But there's KVM, which is what we use, in cloud computing most probably. all that servers that you install has KVM installed, and KVM would basically run everything on the back end as a full virtualization. So here you have two examples of Zen and KVM, and you can see Zen, which is a hypervisor or a VVM, virtual machine monitor, would be connected through these hardware drivers to the hardware. It uses that. Whereas KVM uses its hardware drivers on inside Linux, inside the Linux guest OS, right? And for that, then it uses KVM to forward to the guest OS, to the QEMU driver to virtualize that. Now, just to give you an idea of what it looks like, this is basically an example of using KVM in a physical drive, and here's your VM setting. And so it uses that particular thing. So earlier I showed you VMDK, which is VirtualBox. Most time KVM stores their images as QEMU files, and that's how cloud files also are also stored in the cloud. And I'll show you that quickly now in an OpenStack scenario, because OpenStack basically shows you how you can use QEMU. So let me just quickly show you OpenStack. Not part of the course, but it's just to give you an idea of how does this work. Right, so let me open up a new tab. So I'm going to go to this particular OpenStack system that I'm running this on, and just to give you an idea of what KVM is. So if you look at images here, right, here's all the Linux images that you can use. Like these are all base images, okay, cloud images, and this is how the cloud works. And you have your cow to image format. So what I showed you earlier, this is the disk format, not VMDK, and you use the cow to emulator, the cow EMU emulator to run this, and this is part of KVM, because it basically used libvirt in that case to control how you would assign a VM. So for instance, if I now look at an instance here that I'm running, right, so I can you can see I'm running one instance, but let's say I want to create a new VM. So I would go in your image, which is your image here, your counter image, and you would say, launch an instance, and this is how you would do the cloud. You would give it a name, so we'll call it test, give it a description, and in the source will be the type of image you will deploy. So if I want to use, let's say, Windows, I'll just use Windows 11 for now. And then I need to allocate size to the volume, like because in cloud you have a volume that you assign. Remember when we looked at storage technology, you have the block storage, you have the file storage, and you have the object storage. Now this is block storage here. So I want to allocate, let's say, 50 gig of space to this VM. And then basically I go into my flavor and I select what is the requirements. Now this is the virtual CPU that we just spoke about now. So now you want to say, okay, I want to maybe just use uh, this one. So I've got 4 CPUs, 8 gig RAM, 40 gig disk space. That should be fine. So I want to use that. And so what will happen is when you deploy the virtual machine, it will take that flavor of that 4 CPUs. And networks, you choose your network that you want to connect to. So I'll just use that. Because I'm just quickly going through this just to show you how this works. And when you're done, you say launch your instance. Now, if you have resources available, it will allow you to create that. So it does the block device mapping, which means it creates the block, the volume block, and it gives you an IP address, which is part of what it needs to do. And then if that's done and it's building the whole VM, you don't have access to the virtual machine, but you need to use SSH. So again, that is just showing you a quick way of how you use OpenStack, virtualizing with KVM, and on the back end, you will know the theory, but on the front end, this is basically how you have to set it up. So while that's running, I'll just quickly go to the presentation. So this QEMU here, and using a KVM, is that driver that allowed me now to spin up that Windows 10, Windows 11. It's allowed me to spin up that VM by using the Linux kernel of KVM and the QEMU emulator. And that allows me to have that cow file. So I'll show you now again. Here's the principles of what you're seeing now. So we have the virtual machine monitor. In this case, you could say that's OpenStack because that's the one I showed you now. and it runs the KVM module. On top of that, it has the libvirt KVM, which then communicates. And then again, you have the QEMU emulator that emulates how to, emulate that particular operating system and trying to run now. And then you can see the guest mode here is basically just the user mode, which I now try to access. And then the kernel mode is from the Linux side, from the server side. So this is basically another view to show you basically how this whole libvirt controls your virtual machine. So you have your Linux kernel here, and you have your hypervisor in Zen. So again, it's the same scenario. I just created one VM using the QME emulator, and using the libvirt, which is the APIs, to communicate to through the process. So basically, before I jump to that, I'm just gonna see how far this thing is. So there's still block device mapping. Let's refresh. Uh, I think it's still busy building because I asked for 40 gig. So if I go in here, you will see that basically it's still building. It created a security group for the VM, and there's no volume. So we need to have a volume attached, otherwise we won't have access to this virtual machine. All right, so with that, you have the quiz, and the quiz basically is just telling you what we looked at now. So we looked at in full virtualization, you have your virtual machine monitor that's used for CPU and memory utilization, and you have the guest device for input output. Your guest always needs to be modified to coordinate with the VM. And so that method provides high performance and poor scalability. That's wrong, so that's false. Because remember, we said in full virtualization, the VM is basically, actually in root mode. So you don't need to, modify the guest and that. And then the last one is libvirt is a library on Linux which aims to provide universal and stable software layer to manage virtualization modes and VMs. And so that is true. That is what libvirt is. Okay. So that is, guys, the end of the basics of cloud basics. The others would be more in detail, specifically focusing on Huawei. There you see there that one is running now. So if I go into test here, I can go into the console, and hopefully it will show me Windows. And there you can see there it's spinning up Windows. So what this is doing is it's using that Vertio IO that you saw earlier in the slides. So it's using, where is it now? Not this one. Yeah, Vertio, using this particular driver now, in order to spin up that Windows 11. So that's basically how you use it. So you can see basically it's busy at getting ready Windows 11, and after that's done, it will probably ask me more information to install it. But that's basically how you can use virtualization technologies in the cloud. So OpenStack is like a local cloud, not really the cloud, but it allows you to run virtual machines the way you would run in the cloud. If you go to the likes of AWS or Azure, you would have the same, and you can see here connected to QEMU. That's the instance emulator. And that's basically what I wanted to show you basically on this. So students, with that, let me stop the recording.